In this video, I'm going to explain an action potential. Action potentials are messages sent by axons. An action potential causes a movement of ions across the cell membrane of a neuron.
As you see, the dendrites and the axon terminals at both ends, and in the middle the axon where the signal travels. Now let's take a closer look at the axon.
The chemical events behind the action potential make sense if you remember these three principles. At the start, sodium ions are mostly outside the neuron and potassium ions are mostly inside. When the membrane is depolarized, sodium and potassium channels in the membrane open. At the peak of the action potential, the sodium channels close. The action potential happens when there's a high concentration of potassium on the inside of the cell than on the outside, which means the potassium will want to go out. The outside of a neuron has a higher concentration of sodium ions and a higher concentration of potassium inside the neuron. The sodium-potassium pump helps regulate by pumping out 3 sodium and pumping in 2 potassium. When a neuron is stimulated by a presynaptic neuron, it causes the sodium channels to open, letting in positive ions, which make it more positive on the inside and less positive on the outside. Threshold is at negative 55 millivolts. If you do not meet threshold, action potential does not occur. At this point, all the sodium channels open and many sodium goes into the cell, which will cause the potassium to exit through the potassium channel. The neuron reaches a state of hyperpolarization, which is an increase in the negative charge inside the neuron. The leaking ion channels fix this in the sodium-potassium pump. That will help repolarize the cell back to a normal resting potential.